Descriptive Statistics Part 2, Examining Relationships. In this program, we'll consider three methods for examining the relationship between two variables. It's important that we choose the correct method depending upon what type of data being used, categorical or quantitative. To examine the effect that a categorical variable has on a quantitative variable, we compare group means. In this case, the categorical variable is the independent variable. The quantitative variable would be our dependent variable. By grouping the quantitative data into categories of the IV, or independent variable, we can see the effect of the independent variable on the dependent variable. In other words, once we group the data by category, do we see any difference? We get two or more separate samples of quantitative data, and then we use our same method for examining the distribution of a quantitative variable, looking for shape, center, spread, and of course outliers. Using the Excel tool Descriptive Statistics, on the data page we simply input a quantitative variable number for our dependent variable, here number 3, amount charged. Our grouping or independent variable will be gender. Next, click on the Worksheet tab, Grouping. Input the categories one at a time. This will allow us to examine the distribution of each group or gender category one at a time and see any differences. Once the data are grouped into separate samples, we can see and report descriptive results for each group. The summary statistics X bar, S, and N are always reported. We could see that the women, on average, spent more than the men have a greater standard deviation, and the separate sample sizes of 49 and 60. Neither sample shows strong skew. Neither sample has any outliers according to the z-scores. Importantly, the women on average spent about $775 more than the men. Let's go to the Excel tool now to practice using our grouping tool. We just looked at grouping the amount charged by gender. So our dependent variable is variable number 3, the amount charged. Our independent or grouping variable would be gender, variable number 4. That's all that we need to do on the data page to use the grouping tool. The actual grouping happens on the worksheet Grouping. Tapping on the Worksheet tab Grouping, we simply input the grouping category one at a time. Let's start with F. Here we could see the sample mean and standard deviation, our box plot, and we can see that there are no z-scores beyond 3. Let's look at the men. Here we see the mean change down to about 36.95 for our sample of 49 men. Again, we don't see strong skew or outliers. What we're looking for here is the difference in mean spending between the two groups. Let's try another one. Back on the data sheet, we're going to keep our dependent variable amount charged. But let's now group by variable number 5, education level. On the grouping worksheet, we can see the spending for the BAs, the Ms, and the Ds separately. Again, we're examining the distribution just like we would any quantitative variable at this point, looking for shape, center, spread, and outliers. But when we're considering the effect of the independent variable on the dependent variable, we're adding the observed mean difference between the groups. To examine the relationship between two quantitative variables, we use simple linear regression. Both the independent and dependent variables would be quantitative, and we're interested in the effect that the independent variable might have on the dependent variable. And by effect we mean, does the dependent variable change as the value for our independent variable changes? We begin our regression analysis with descriptive statistics, looking at the form, direction, and strength of the relationship between our two variables. Form can be either linear or nonlinear, as seen on a scatter plot. The direction, either positive or negative, indicated by our sample slope. Our correlation ranges between -1 and +1 and is a good measure of the strength of the linear relationship between two variables. It's notable that correlations are considered very strong when they are beyond 0.75, either positive or negative. Using the Excel tool Descriptive Statistics, we simply need to input variable numbers for both the independent and dependent variables. Here we've input variable 6 as the independent variable and 3, the amount charged, as our dependent variable. We have two result sheets for our regression tool. One, the worksheet regression, shows our scatter plot, our regression equation, and our correlation. The worksheet residuals is used to check for regression outliers. Positive linear trends indicate that as x increases, y should also increase. Trends might also be negative. The slope estimates the average change in y for an increase of 1 on x. Here, our slope is $58.69, which shows that as a cardholder goes up 1 year in age, their spending should increase on average by that amount. Our regression equation can be used to make simple predictions about the dependent variable given a value for the independent variable. These predicted y values have the symbol y hat. R squared, the coefficient of determination, measures the percentage of variability explained by the regression equation. In other words, about 34% of the variability in spending can be explained by changes in a cardholder's age. Residual analysis may be used to check for regression outliers. Outliers are extreme residuals, or deviations from the regression line, and weaken the overall linear trend. In general, less residual indicates a stronger linear relationship. We could see residuals in two ways. On the scatter plot, residuals are differences from the regression line. On the residual plot, we see the residuals relative to 0, or no residual. Regression outliers, or these large residuals, stand apart from the other data and are relatively far from the regression line. Our Excel tool worksheet residual will flag any residuals that have z-scores beyond positive or negative 2.6. Summarizing the regression results, examining the relationship between age and amount charged, we see a positive linear relationship. R, the correlation, is 0.5850, which indicates a moderately strong linear relationship. This shows that as age increases, frequently amount charged also will increase. Our predicted amount charged, or y hat, equals our slope times age plus our y-intercept. This equation explains about 34%, that's our r squared value, of the variability in amount charged. And our residual analysis shows no regression outliers. Let's go to our Excel tool now to practice using our simple linear regression tool. Remember, we're still just doing a descriptive analysis examining the relationship between these two variables. So using our regression tool, we can input the variable number 6 for independent, that's age, and variable number 3 is our dependent variable, amount charged. On the Worksheet tab Regression, we see our results. Our scatter plot shows a moderately strong linear relationship, and we can support that with our correlation coefficient R. Our equation is also given. We can consider simple predictions given a cardholder's age using our equation. For example, we see in the data a cardholder who's 28 and who spent on the credit card $1,837. If we input the value 28, we see that the regression line predicts much greater spending than what we see for this particular 28-year-old. Remember, the difference between the observed y value and the predicted y value is a residual. That's affecting our r-squared value and the strength of the overall linear relationship. On the Worksheet tab Residual, we can see that the regression equation predicts much more spending, $1,744.53, more than what this cardholder actually spent. The z-score of that residual is negative 2.217. Remember, the regression tool will mark any residual that's beyond 2.6, either positive or negative. Let's try another one. We can also consider the relationship between income and amount charged. Because both are quantitative variables, income is independent, amount charged is dependent. The Worksheet Regression has our results. We can see that income has also a moderately strong linear relationship with spending. R is 0.6249. Our r-squared shows that about 39% of the variation in spending can be explained by changes in cardholder income. Looking at our residuals, we see no clear regression outliers. To examine the relationship between two categorical variables, we use CrossTabulation. In this case, both the independent and dependent variables must be in categories. We examine the relationship primarily using the conditional distribution and the clustered bar graph. We're looking at each category of our dependent variable and what percentage of the independent variable groups is in each. For example, we could see big differences in the low and high categories between men and women. But in the middle category, we see similarity. Similarity indicates near independence. Differences show strong effects. This method is similar to the group mean analysis, except instead of comparing just two means, we're comparing the percentage in each category. Using our Excel tool, Descriptive Statistics, we can easily create a cross-tabulation to show the relationship between gender and spending category. We need to input variable numbers for both independent and dependent variables. Here, variable 4 for gender and 7 for spending category. Remember, when we're inputting categorical variables, we need both the variable number and the categories. Also, in this case, we're using a grouped form of our dependent variable amount charged. Often in statistics, we regroup or transform data to suit a particular method. We report results by showing the conditional distribution by independent variable category. Notable differences are reported. For example, women are much more likely to spend in the high category of spending than the men. These differences indicate effects. For example, 4 out of 49 of the men, or only 8%, spent in the highest category, but 22 out of our 60 women, or 37%, spent in the highest category. Here, the strongest effects are in the low and high category, but not much of an effect in the mid category. The clustered bar graph is a powerful visual showing that conditional distribution. Let's go back to our Descriptive Statistics Excel tool to practice our cross-tabulation. We're going to input variable number 4 for gender, as well as the two categories M and F. Variable number 7 is the grouped form of our dependent variable spending. And we have the data grouped into 3 categories, low, mid, and high. Our crosstab worksheet has our results. We're particularly interested in the conditional distribution by independent variable. These percentages simply show the result of 21 out of 49 or 24 out of 49. That's what we mean by a condition. We're looking only at the men or only at the women. Differences in these percentages indicate effects. Similarity indicates very weak effect. The clustered bar graph is a very powerful visual showing those differences very clearly. Let's try another one. Remember, we need an independent variable that's categorical and a dependent variable that's categorical. So let's try education level variable number 5. For our independent variable categories BA, M, and D. Our worksheet tab crosstab has the results. Here we can see that there is not a particularly strong relationship between education level and spending category. We see some notable differences in the mid category and in the high category, but not nearly as much of an effect as we saw between gender and spending category.